Hello. In this video, let's take a look at the stepper motor, and we can talk about how to use it and what it can do for us. The stepper motor, on the downside I suppose, is relatively large and heavy. Here's a stepper motor right here. It's not light and not cheap, and it's somewhat complicated to get it to go, I suppose. And it does use a bit of energy, so those are all the downsides. So what is the reason for perhaps using a stepper motor like this? Well, the stepper motor, the real upside is that you know exactly where the angle of the shaft is at any one particular time. So as this thing rotates, again, you know the position of the shaft, and then you would know the position of what is connected to the shaft, like a robot arm. We use it for a robot arm so we know where the robot arm is. They have been used in printers and XY plotters and 3D printers and assembly lines, robots. Here's a motor, and on the back of it, it's labeled with its characteristics. It says it's 5 volts, and it says that every single step that it takes is 7.5 degrees. It has 4 wires coming out of it. With 4 wires coming out of it, it's a bipolar motor, a bipolar stepper motor. And the bipolar stepper motor requires a certain circuit to run, as opposed to the unipolar, which has an easier circuit. Here's a unipolar stepper motor, and we can see that it is a unipolar stepper motor because it has 5 or 6 wires coming out of it. This one has 6. On the back of it, it's not labeled, so we would use the guess method. But I've used this one before, and on it I've written down that those color wires go in this order: 1, 2, 3, and 4. Those colors go in that order. If you take the shaft and you rotate it, you will feel the clicks, the steps in the stepper motor. So what is this order of the wires that I refer to? Well, the motor will have 4 wires that you need to step, A, B, C, and D. On the unipolar, it's A, B, C, and D, and then there's 2 common wires. You can determine which of these wires are which by using an ohm meter. So the A, B, C, D inputs to the stepper motor, 2 of them are on and 2 of them are off, and they step in the sequence. And as you go through the sequence, either down or up, the motor goes either forwards or backwards. So you can take a step, stop, wait, take another step, stop, and wait. This waiting period is, as a minimum, I would say 1/100th of a second. I wouldn't go any faster because the motor really won't go any faster. It will stall if you try to. But you can go much slower. You could have, if you wanted to, 2 days or 3 days between each step. You can sit at each step forever if you wish. So you can go pretty slowly if you need to, or even stop. Now these values going to the motor are not the 1s and 0s that I really allude to here. That's what's coming out of the microprocessor. And between the microprocessor and the motor, we will need to have a circuit that drives the motor, a circuit that passes energy into the motor. The microprocessor doesn't have enough energy to run the motor, so we use a circuit similar to this shown on page 214 of this particular book. There's the circuit, if you can see it, but it is a push-pull transistor circuit for, in this case, the bipolar stepper motor. It consists of an NPN, a PNP, some resistors. It's a bit of work to construct. That one circuit needs to be replicated 4 times, once for each wire. On the other hand, the unipolar circuit is easier. It's smaller, and it looks like this on the prior page of the book, page 213. And you can see right there is the one transistor and 1 resistor per each wire of the motor. Now, so what's inside of a stepper motor? Well, let's move this out of the way. And if you were to open up a stepper motor, you would see some teeth. This example here is from a linear stepper motor. They're not very common, but they're nice to look at. Here, instead of going in a circle, this one goes in a straight line back and forth, kind of like what a printer might need. So the top on the left, the top where my finger is on the left there, those, if you energize them, will align with the pins on the right. If you then energize the middle position, it will then rotate to make the alignment. And thirdly, if you then go to the next state and energize where my thumb is, this will then align with the pins and then shift again like this. And if you keep that pattern up, top, middle, bottom, the carriage will then step, 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 step in that direction. If you want to go in the other direction, you reverse the order of the energization. You would energize the bottom, middle, then top, and it will go step up, step, 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 like this. So, like I say, there's a bit of work that you have to do to get the stepper motor to work, but you know, it does have that advantage of it can, you know, the position of the motor, which is very nice. One last little bit about the stepper motor, and that is another difficult part is with these 4 wires A, B, C, and D, one may not know the order of the wires. So what color is A, what color is B, and so on. You might have to use the guess method and try the different wires on the different A, B, and C values to see which and when the motor goes properly in a forward direction.